Hey guys, welcome back to the WeeW. So this is the tutorial for the STM32F1 and we are working on the UART communication. So generally speaking, we have been looking for the UART library and we have created a library with a basic function, and also we have been using the UART interrupt to optimize our communication protocol without impacting too much the main program. And for today's video we are going to take a look on understanding an advanced communication strategy for the UART. It can be a little bit overwhelming, but when we have a communication with different other senders and receiver, sometimes it's very important to save the right information. And today we are going to create a program that will work and update and give the right message for the program so you get the desired output. It can be a little bit overwhelming, but I prepared some explanation graphs that will help us to work on this one. And after that, after understanding the strategy and how we can manage this communication, we will go of course through the library and try to update and create the library related to this one. Finally, we'll create a function. This is a bonus one, an input function. It's a simple one. That's a function that send an input to the a message to the user and wait for it until it gets it. Good. Before we go deeper, there is one point that I need to share with you. So I've been working on the this program, and I found out that this strategy is quite this algorithm I've been sharing with you had one mistake, and this is instead of 80 must be 00, because the 80 means the program is still busy and not ready to send. So if we do so, the program will have some issue and you have some lag in your program. And by putting 0 until it is equal to 0 means the program is still, you cannot send. And then so when you put it like this, you can go back to this send and remove this delay ms, and you will have a more optimized function to send. Okay, good. So now as we optimized this and corrected the UART communication, let's go take a look to the chart and start working on our strategy. Okay, so I always put this graph in the first place because I always find it very important. So we need to have the microcontroller doing some important stuff that it's intended to do, and just goes to do other stuff when the message is updated. And each time it's very important that we do have the right message for our program, so we get the intended output. And to do so, that's a strategy in the UART-ISR I'm implementing to get this program. So we said, like before, the bridge strategy for those who don't who are just getting to these videos. The bridge strategy is when the UART is just putting the communication between two devices. It's just a postman, but what is important here and where it is useful, if both devices have a different baud rate, specific one, so the UART can be very helpful to manage these kind of issues between other devices. And the other one is, after that we have to choose between the Terminator strategy or the interrupt strategy. The Terminator strategy is the guy coming from the future to save the future. Apologies, it's just a joke. The Terminator strategy is the one where you define which would be the last char in your message that would define that your message is ready. And by choosing this strategy, so each time we detect the if we don't detect the terminator or the one intended to be the last message, we keep updating and incrementing our message. Else we flag that the message is ready and we can go and make some stuff based on this message. On the other hand, the interrupt strategy, the name is a little bit tricky, but the interrupt strategy, the strategy we start running an interrupt or counting the time based on the response of this sender For example, if I don't know the length of my the message, final message, because it's dynamically changing, I'll output see the time that I should getting the message for. Let me give you a more practical example. If we do have the ESP01, the ESP01, when it scans the network, it takes a bit of time to run everything and to give you the feedback. So at that time, I know the Terminator, but I'm not sure about the time that the ESP01 will take to give me the feedback about the list of networks in the area. So it's better to wait for the full reply to a certain time than putting a Terminator. So the interrupt strategy will initiate the interrupt for the SysTick timer each time, and inside the SysTick there will be a different function that will be looking for the counter and saying, because counter this one, we will put, for example, 10 or 9, how much time we need to increase. And each time, if it's decreasing, if it's not 0, it just keep decreasing and going back to the next interrupt, else it will flag message is ready. I hope so far this is not overwhelming, and when we will go through the code, this will make more sense, and I hope your understanding will be better. Great. So to do so and to implement this strategy, we will need to assert certain variables. So we have been looking for the count variable, which is a variable that is incrementing each time when we are receiving a message. And then the signal variable, this is the one coming here and here and here, and this is the variable that says that my message is ready. Next, we do have the bridge variable. This is the one to confirm the condition, if we would like to have the bridge or not the bridge condition. The terminator should be the terminator for this one. This is for this condition here, to say if we are going to choose the terminator or the interrupt strategy. The terminator char will be the one for this condition, and this will be the specified char for the last digit or the last char of my message. Finally, so for the terminator, if a terminator is 0, we will be using the interrupt strategy. And if we are going the interrupt strategy, we will need to keep a constant for how much time we have to wait, and the one which is each time turning here to 0. Okay, great. So one of the most suitable solution for this activity will be to use a structure, but as I promised for this STM32F1 tutorial, we will go through an intermediary level of C programming. So we will be solving this issue using arrays, and that will be an interesting way to see how we can go through and update the system accordingly. Okay, so I will create an array here. Let's call it unsigned short, and let's call the UART1 manager, and it should be having 7 variables, or 7 actually in memory slot. Okay, 5, 6, and 7. Okay, we do have the right number. Good. So we will create this one, and we initiate everything to 0 for the moment. Okay, and okay, so here will be 2 and here will be 3. Fantastic. Okay, so, and just for the information, we as I'm using for the STM32F1, I'm using the blue pill that we can see here. Just a moment. Okay, so this is the blue pill, and the blue pill would have the UART1 wiring as intended for the USB communication. So for my program, I would not be able to use UART1, and this one I will just put it as a comment, but we will need to put it as a full library. Okay, so let me comment. I will keep only the manager to run the program. to a full library. Okay, good. So now let's take a look to the UART-USART function that we have been building and implement it and see how we can change it accordingly. Okay, so this is our actual UART-USART library. So what we do have the bridge. Are we using the bridge strategy or not? And after that, immediately we check the last digit. If the last updated digit in my message is equal to the new line, so we can signal 1. And in this one, so it's really specific. It's a really specific way of the whole strategy. As you can see, this is a bit more general. And also, we can see here there's too many inputs and a little bit overwhelming. So what we can here change is just put UART manager. So we just input the UART manager as a chart, as an array. Okay. So we have been saying so far. So the UART, the bridge is the index number 2. So we go to the bridge and we update it. This is 2, and here the bridge variable 2. So the counter is number 1 here. So it becomes just one input. No, it's number 0. Let me copy because we use a lot the counter. Here 0, counter also here 0, and counter, let's make it a bit better, and here the signal is 1. Okay, so let's update in the header file. Okay, so now that we updated the header file, we're ready to start using a little bit this one. And as we said, so first let's test our bridge strategy and if things works as we expect. So we need to go here and correct this one. So instead of putting all this, we just put UART to manager, and for this one UART 3 manager. Okay, so let's use the first strategy at the first place, and let's use the bridge and see if the program is working accordingly. So for the bridge here is index number 2, so we would like to have 2 sending to 3 and 3 sending to 2. Let's save. Let's open the HTML program. Okay, so as you have seen in the previous in the video, so we do have the 2 FTTI connected to my STM32F1, and I'm not sure which com is which UART. So I brought a small program here. So for UART2 will say this is UART2, and UART3 will send this is UART3. We should receive. Okay, check and see. Okay, so the COM3 is UART2 and COM6 is UART3. Perfect. Okay, and let's try to make some communication. Say like, for example, if I send hello, yeah, I'm receiving hello, perfect. And then the other one, this is WeeW. Okay, so we have a clear bridge strategy working without any issue. So we can go now and work on the Terminator strategy. So let's go here and update our Terminator strategy. So we have been saying that we would like to have a specific, not anymore a specific Terminator that we put here, but something that we put within our manager. And in the manager, if I have the UART strategy, so first Terminator, first 0 for the bridge, and then we should have 1. Yeah, let's build the condition first. Okay, let's take a look to this one and start building it. So after updating my and getting my message, so this is okay, this is my Terminator strategy. So I can put here not anymore the /n, but sorry, wrong one, but it will be UART manager. My Terminator char is 4. Okay, so I'll be something that I'll be choosing within the manager. Okay, so here, if my UART manager 3, so if it's 3 here, if it's 3, then okay, we can use the Terminator strategy. Else we will be using the timer strategy. Yeah. Okay, good. Let's check there's no issue. Okay, no problem. And let's put, so we are going to use here, this is 1, this is also 1, yeah, and which we can use, yeah, this is a very important thing, the UART communicate using char. So if I want to set up something even for a 0, I should not put a 0 but put the char of a 0 here. Okay, if I detect the char of 0, I will understand my program is ready for my program has received the whole message. So let's check. So this is 1, 2, this is the preach strategy, this is the Terminator strategy, and this is the char that I'm being looking for. Let's check again here. Okay, 4, 3, perfect. Okay, so let's clean everything. So clear, 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 clear to have a right communication and a clear one. Okay, let's send hello. Okay, nothing happened. If I add the 0, nothing keep happening. What's the issue then? Okay, if message you are 3, this is my 0. Yeah, I understand what's happening. Quite very simple. I forgot also to update the main loop where I need to detect my signal. That's a good point. So let's write UART2. Okay, this is the old program I used from the previous video. So this is 1, and here this is also 1, this is 3, and this is here 3, and here this is 3. So this is the main loop where the signal is notified, and in my IRQ it's the array that has been updated, not the variable anymore. So here it's will be 3. Okay, let's clear, clear, and clear to be quite accurate, and send. So now let's say hello. Okay, hello, nothing sent, 0. Yeah, we do have the whole message now. And let's clear and try a more complicated one. Even we put a really long message. If I don't have the Terminator, the message is not received. Let's check on the other side. So, hi, this is WeeW. Yeah, but nothing happened. Adding the 0. Yeah, we do have our message here. So the Terminator strategy now is quite well implemented, and we can go and start working on the interrupt strategy. Good, let's take a look to the interrupt strategy. So for the interrupt strategy, first I have to start and enable the interrupt. So that's what we are going to do now, and this is within the char here. So before we have the interrupt, we have first to initiate or start putting this one, the UART manager, okay, and also initialize, as I put it here, initialize my in this one the time counter. So I'll be counting how many time I'll be running again and again. So if I go here, so I have to put the UART manager here, UART manager of 6, sorry, will be equal to the UART manager of 5. This is the constant I'll be turning each time. Okay, and then let's call or create a new function. Let's call it SysTick. Not SysTick init, this is a function that we do have, but interrupt start. So we have to, okay, we do not have this function and we are going to create it right now. And let's go create it in the SysTick strategy. Okay, that's almost same that the init one, but this one will be generating the interrupt. Also void here, any input variable. Okay, and we almost copy the same thing with a small difference. So this is just preparing the SysTick, but first we put a 7 here, as 7 means we are initiating the interrupt, and we have to add the disable IRQ, enable IRQ. Okay, and I would like my program to run. So I have a 72 megahertz running speed. So I'm putting it 720,000. So almost, it's around 1 millisecond. So every 1 millisecond I will implement. So the count I will be putting, that's the one will be incrementing how much time wait I will have. Okay. Okay, so far so good. Perfect. So let's now, so we created now, so we initiated the interrupt. Now we have to create the SysTick init function. So this is the function where the all the program will be doing this loop and counting and checking again. Okay, so for the SysTick init, so it's a void sys, not init but interrupt, SysTick interrupt. The input will be the unsigned short each time. As for the UART manager, UART1 manager, we have to put all the 3 of them manager, but the logic will stay same, so that's not a big deal. This is same as the other function that we have been working on so far, where we need to specify the 3 managers, 2 and 3. Okay, so the first thing to check, so if let's take the first UART, the UART1 manager of 1, so if the counter is not 0, I don't need to even bother for it. So if the counter of 0 is different, so if it's different to 0, we can go inside. Okay. Okay, yeah, I forgot to put it as an array because the UART manager is an array. Okay, So if it's different to 0, so if the counter is different to 0, what we have to check is if, again, the UART manager, this one of 6, is equal to 0. Okay, so if the UART manager of 6 is equal to 0, then what we have to do, so it means if I counted all the time that I had, so what I have to do is just put the UART one for 0, yeah, equals 0, reinitialize my my counter, and then also UART manager of 1 is equal to 1. This is a signal saying that my message is ready and I can be go to the main program and process it. Else, okay, I have to decrement my counter 6, the initialized one. Okay, so this is for 1, and we need to repeat the same thing for all the others. So we just put else, copy the remaining, yeah, and before that we also have to close. We have to close the UART. This is by the interrupt for the SysTick, and just by putting the SysTick init function, which is not that will stop the interrupt. Okay, and after putting else, we just put like this, and we change UART 1 by UART 2. Okay, and last one, the 3, here, 3, 3, 3, 3, and 3. Good. So now we do have everything correct. Yeah, we have to add this function to the header. Okay, and also we have to include the SysTick time to the UART, because it doesn't recognize yet this function here. Okay, it should be recognized. No, not yet, because I didn't declare it here too. So this one here, yeah, I should add this one and this one. Okay, one warning. Yeah, the end of this one I should add one space, and here we are. Let's check. Perfect, perfect. So now we do have the full program working, and let's start testing it. Yeah, before, yeah, of course, always, yeah, I should not forget the void for the SysTick handler, which is just SysTick. This is the function that will run the heuristic interrupt handler. Handler void. Okay. Okay, and we just put the SysTick interrupt function. Okay, and as input UART1 manager, UART2 manager, and UART3 manager. Okay. Okay, so now let's change the strategy by putting 0 here and 0 here. So we are moving to the interrupt strategy, and we should have our interrupt ready to run. So let's make a first test. Save. and the first test will be just to see if my interrupt is running correctly when I go through this strategy. Okay, so I will go to the debugging tool, run my program, and go to peripherals, core peripherals, system. Yeah, it's already open to get this value. So right now, as we can see, we do see here 5, which means we don't have any interrupt. So we need to do what we need to do. Let's close this one, clear as usual, just to have a nice picture of what's happening, and send a message. Just send one chart to see what's happening. Okay, it's not running, and let's check why. Do we go? Okay, just no, this is a drive. Go to the C and try to check if we go through here. So if we do this, else we are going here. So let's send another char and see where are we going. Okay, so my UART manager, let's check. Nothing has been received for the moment, so if it's not a bridge strategy, and here nothing received. Okay, let's try again. Okay, it stopped here, perfect. Okay, it went here, it went here. Okay, we do have, okay, it worked. And we received it with a lag. Perfect. Okay, let's try to send something else. AA, and see. Okay, that's bad, my bad. Okay, let's stop all the interrupt. Yeah, we didn't receive everything because I've been stopping the reception, and we'll lose immediately the char if we have this kind of stoppage in the program. So let's put WeeW. Okay, it's almost immediate. Hello. Okay, so now what we can do is close the debugging mode, because it's almost immediate when we do have a 0. Okay, there's a problem. SysTick is invalid here. Patch check. Okay. No, this is why we do have this issue. Okay, the program says it's no problem. This is something start happening recently, but it should be fine. But here, let me increase the time that we need to do, and let's put it to 100 to see if we do have the lag in the program that we are running. Okay, save, run. Okay, so let's clear and clear everything and put hello. Yeah, you can see that we had a lag of 1 second. Let's make it more, just to see how far we can go. I mean, like, to see really the lag that's happening. We should have 5 seconds, around 5 second wait. Okay, clear, clear and clear. Say hey. Okay, sorry. Hi WeeW. Okay, it takes a bit of time. Yep, and we have the hi WeeW. Perfect. So now we have the complete strategy. So you can see that you can put a time lag and waiting enough time for the response. Good. So now we have created this one. So let's work on the other and final function. It's a small one. This is a function where we are going to just get the reply after a certain time. So let's call it and go here. I called it the yeah, it disappeared, you see. So that's just a small problem. And this function that we are going to create is a void UART send, and we will need to send like an unsigned. So the first thing is just which UART are we going to send with, unsigned short, and also the char we are sending, which is an str, just generic name. So what we are going to do is just to send it already, we already created, always choose the same name, we call it a message. Okay, and for this one we also have the string, but then we also have the unsigned short of the string manager or the UART manager, same. Okay, so we the normal way to put it is to put that the UART send one, UART send function, and that's just you put the UART here. So this is to define which UART we are receiving, UART, and the string to send. So that's a basic function we have been creating previously. But now what we can put, as we have the whole manager, the whole UART manager. So while the UART manager, the string manager of 1, the signal is equal to 0, then we just wait. Okay, equal 0, we just wait, and as soon as we receive the message, we have to clean our UART manager and put string manager here of 1 equal to 0. Okay, and we do have one issue here. What's happening? String, yeah, because I forgot to put this one. Okay, so this is the function that we can use to receive, to send a message to the user and keep waiting, but we can improve a little bit this one, and we can create also a timeout function inside it. So if I have unsigned but long, okay, a variable we call timeout, which will be equal quite a big number. I put it as 72 something. So this is 7,200,000, like this one, quite a big number. And we wait, so we keep decrementing timeout minus here, and we put that we stop and timeout is different from 0. So within this function here, we can even send to the user and have a timeout function saying the user didn't send for a certain time, and so we stop it and we move on. Okay, good. So now we have been seeing all this function, and I think we have been looking for all these strategies to manage the UART. That was the last function of this video. So by the end of this video, so we have been seeing all these strategies, and now we have been looking for the whole UART. So the next video will be about building some function to manage the messages, because we are using a lot of char, and sometimes it's complicated to move from char to integer and having this issue. So for the next video we will be looking more deeply how to use UART and not anymore building the UART function. So thank you a lot for following this video. Hope to see you again, and see you soon. Bye.